So this video is on DC multimeters, and this is chapter 29.7 in the textbook. All right, so first off, most multimeters, ammeters, voltmeters, are based on galvanometers. So a galvanometer is really just a coil of wire and a magnetic field. Now, when you pass a current through that coil of wire in the magnetic field, it experiences a torque. So there's a rotation, and typically then you attach this to a needle of some sort, which gets deflected. And the amount of torque and the amount of deflection just depends on the current. So that's the basic idea. We're going to talk more about currents and magnetic fields in a couple chapters, but that's enough. This is enough for now. Now the challenge though, an actual galvanometer can only measure very, very small currents. So typically like microamps, which isn't very much. So it's not very useful on its own. So what you can do is you can use a galvanometer to actually make an ammeter. So an ammeter is a device for measuring amperage or current. And the key thing to remember, so an ammeter, you want all the current in the circuit to pass through it, which means for an ammeter, you have to attach an ammeter in series. Now, if you want to make an ammeter out of a galvanometer, what you do is you add a small shunt resistor, and you do that in parallel with the galvanometer. So then ideally, the total resistance of your ammeter is very, very small, because after all, we're putting this in series and we don't want it to change what's happening in the circuit. So ammeters should have very small resistance. Ideally, they'd be zero resistance. So on the left here, this is then, remember, an ammeter. You want to measure current, so you attach it in series with wherever you want to measure the current. And again, on the right here shows what an ammeter made out of a galvanometer actually looks like. So the galvanometer is the G. So of course the galvanometer is the coil of wire, so it has some inherent resistance. That's the little r. And then we put the shunt resistor in parallel with the galvanometer. And typically the shunt resistance is something very small, a small resistance, because you want most of the current to actually pass through the shunt resistor, only a little bit of current to pass through the galvanometer. Okay, so how about a voltmeter? Well, to measure the voltage across the circuit device, of course, you don't actually want to disturb the current in the circuit. So a voltmeter is attached in parallel. So, and ideally, you want your voltmeter to have a very large resistance. Ideally, it's going to be an infinite resistance. So what you can do then is you can take a galvanometer and you just add a large resistor in series. So, and then you can make a voltmeter. And we've got a picture here. So again, on the top, so if I want to measure the voltage across this light bulb, well, I just attach my voltmeter in parallel to the light bulb, one lead on either side. Now if you wanted to look inside the voltmeter, that's what's shown here on the bottom. So if this is made out of a galvanometer, so again, little r is just the inherent resistance of the coil of wire, and you add a large serial resistance in series with that. Okay, so then what about an ohm meter? Well, an ohm meter is something for measuring resistance, or ohms. So an ohm meter, what it is, so it's an EMF device, right? So like a battery or something, together with an ammeter. So the idea is, since you've got an EMF device, you apply a known potential difference to the circuit element you're trying to measure the resistance of, and you measure the current, right? And if you know V and you know I, you can use Ohm's law to calculate the resistance R. Now, what this means though, since the ohm meter actually has an EMF device in it, if you want to make sure that whatever it is that you're trying to measure the resistance of has to be removed from the circuit. Because if it's still connected to other parts of the circuit, well, you're applying a potential difference, which means there's going to be a current flow. And for the ohm meter to work, you need all of that current to flow through the resistor or whatever it is you're trying to measure the resistance of, not all the other stuff it may be attached to in the circuit. So you need to remove it from the circuit so it's by itself. So let's say I have a light bulb here, I want to measure the resistance, so I just attach my ohm meter to the light bulb and nothing else.